I also want to show you how to reverse engineer the circuit parameters from the transients. So here we have an RC circuit, and we are told the voltage and current values for times greater than 0. Just note here that the current is specified in milliamps, and the question says find what's the resistance, find the time constant, and then find the capacitance. I kind of work backwards from these. So firstly, to find the resistance, well actually if we know the voltage and the current through a resistor, well we can use Ohm's law and just calculate resistance directly from that. So use Ohm's law. Now we just want to pay attention to the signs here. So we have a voltage and a current which are defined in this way as they're drawn on the diagram. So the voltage across this resistor is the same as the voltage across the capacitor, right, the way that they're connected. And so we see that the current enters the negative terminal. So the current here goes in through the negative terminal of the way that voltage is labeled. So the Ohm's law that we should use for this is V is negative times IR. And we can basically substitute in the values that we have. So we had for voltage was 200 e to the minus 50t equals negative of, and our current was 4 milliamps, so just being careful of the milliamp unit there. And that was also negative, so we have two negatives, times e to the negative 50t times r, times the value we're trying to find. I'll just write capital R to match my diagram. So we can solve this equation. Basically, if I look at this, I see that the exponentials can cancel on both sides. We can divide through by that exponential because it is never equal to 0. And we just have some numbers to calculate. So we have resistance is just 200 divide 0.004. So our 4 milliamps, so 200 divide 0.004 is 50, excuse me, let me draw that, 50 kilo ohms. So we know the value of the resistance. Then question asks us, well, what's the time constant? So the time constant is like e to the negative t over tau is the value of tau in that expression. Time constant is tau in e to the negative t over tau. So what we have here is that basically it's negative 50t is what we observe in our actual expressions. Negative 50t is equal to negative t over tau. So basically solve for value of tau. So bringing that to the other side, cancelling the t's. So t's will cancel, negatives will cancel, and I have tau is 1 over 50, which is, so 1 over 50 is 0.02 seconds. Basically 20 milliseconds. You could also write it like that, is 20 milliseconds. And so from that information, it's then fairly straightforward to calculate the capacitance, because we also know that tau is resistance times capacitance, so we can substitute in the values that we have and directly get our capacitance. So that's 50,000 times our capacitance. So our capacitance is 0.02 divide 50,000 is 4 microfarads. I'm sorry, 0.4. I'm just reading the decimal points wrong on my calculator. 0.4 microfarads for that one. So basically, yeah, with the values of the current, with the expressions, we can sort of reverse engineer and go back to what our what our circuit parameters would have been. Another way that we could have found capacitance, by the way, alternatively, we know that the current through the capacitor is C dV dt. And so we could have substituted for our current and substituted for our voltage and solved for capacitance in that way. And so alternatively, you use I equals C dt, substitute I and V, and then solve for C. But if you already have the time constant and the resistance, then that's probably the faster way to do it.